Welcome back to College Algebra. We are working through our refresher central notes. We left off with lines. This is our last group within our refresher central notes. So this is, again, a reminder and a refresher of what we did in intermediate algebra or what you've done in the past if you didn't get a chance to take intermediate algebra. So let's dive right in. Okay, so in order to proceed through this section on lines, I want to make sure that you are familiar with the terminology. So you are going to see linear equations in these 5 forms within this section. Our first form is where our variables are on one side and the constant is on the other, and that is called standard form. Our second form is in y equals mx plus b, which represents slope intercept form, where m represents our slope and b represents our y-intercept. We also have the form y minus y sub 1 is equal to m times x minus x sub 1. This is called point slope form. You will use this form if you have a point and a slope. Next, we have a vertical line that will always be of the form x is equal to some sort of constant. So for instance, with this example, x is equal to 3. This is where our line crosses through the x-axis. So here's my x, here's my y. This line will cross through the x-axis at 3, 0, and all of the other coordinates where x is 3. And that's kind of the point, right? So for instance, this is 3, 0, 3, 1, 3, 2, 3, 3, etc. So x is always 3, which lends itself to this idea that that must mean the equation of the line is x equals 3. Similarly, we have the form y equals a constant, and that's going to be a horizontal line. So something like y is equal to -1, that will actually go through the y-axis, and it will represent that horizontal line. Okay, moving on, we want to next talk about slope. So as a reminder, I want you to consider that slope is a rate of change, right? So in essence, when we think about slope of a line, we think about the change in y direction, over the change in x in that x direction. So slope essentially is rise if it's positive or fall if it's negative, always over run. And you're always running forward. So for instance, if I had a little mini graph here, this is my little mini baby graph, and I went ahead and I drew a line that looked like so, we would see that we have a positive slope. We're going uphill. So we know that we are going to rise before we run to find the next point. So you rise and then you run. Similarly, if we have negative slope, we would see that our line looked something like this, as in it was going downhill. So we're going to fall before we run. And that's really important as we plot our points. We always fall before we run. And notice we're running in the same direction. The numerator of our fraction will always tell us whether or not we're rising or falling, but the denominator will always tell us we are running. Now, we have a slope formula here. This is something that you should have it committed to memory. If not, I would definitely practice with flashcards. Put this on one side, write slope formula on the other, and then actually practice, making sure that you commit this to memory. So to find the slope, or our m, it's the difference in your y coordinates over the difference in your x coordinates so that you are consistent. So notice we have y2 minus y1, then x2 minus x1. We could essentially say, what if we actually reverse those coordinates? That's fine. So for instance, in your new slope formula, you could write y1 minus y2 so long as it's x1 minus x2. So regardless of which point you use as point 1 or point 2, it doesn't matter. You're still going to obtain the slope between those 2 points because you're either rising and running or falling and running, regardless of which one you include as your first or your second point. All right, let's take a look. We have a few problems here where we are given the opportunity to identify the slope between the points, and then we'll indicate what is that vertical and horizontal movement. AKA what's the rise or fall and what's the run. So we start by labeling our ordered pairs x1, y1, x2, y2. And now we're going to actually plug into our formula. So m is equal to, I'm going to use the traditional formula, which is y2 then y1. So we have -2 minus 3 all over -4 minus 1. When we do this math, this is going to leave us with a -5 over a -5. And we always have to simplify our fractions. So this is going to be a 1 over a 1 when we divide. Notice the negatives will cancel out. So negative divided by negative is positive. And 5 divided by 5 is 1. So what this means is that we are going to rise 1 and then we are going to run 1. And that is our slope. If you plotted these 2 points on a graph, you'd actually be able to see that between those 2 points, you're going to end up rising 5 units and running 5 units. So you can physically see that it's going to be a positive slope. You're rising. Sometimes it's helpful to see graphically what that actually looks like, and I highly advise that. Take a look on an actual grid, plot the 2 points, connect with a line, and then count. Count how you would move from one point to the next. Are you rising, then running? Are you falling and then running? And then count the actual distance between those points. Good. Let's do that again. At this point, you can pause the video, try numbers 2 and 3, and then check back. But let's take a look together. For number 2, same thing, m is equal to, and again, if it helps, I'm going to label x1, y1, x2, y2. So we have 5 minus 2 in our numerator, and -6 minus a -6. -6 minus a -6. When we do the math, we see that we have 5 minus 2, which is 3. And then -6 minus a -6 is the same as a -6 plus 6. So we can go ahead and turn that into a positive. So in which case, -6 plus 6 is 0. But we know that any number divided by 0 is actually undefined. What that means is if we actually plotted both of these points, -6,2, -6,5, we would actually have a vertical line. Every vertical line will always have a slope that's undefined. So when we graph it, it's straight up and down, this vertical line, and it actually has the same equation as the numerical pieces or the numerical coordinates of your x coordinate. So take a look at your points for a moment. -6,2, -6,5. They both have the exact same value as their x coordinate, which is -6. So if I wanted to write the equation of the line, I would say the equation of the line is x is equal to -6. So I could take it a step further. I know my slope is undefined, and now I know for a fact the equation of the line is x is equal to -6. Similarly, take a look at C. Notice if we label these x1, y1, x2, y2, your y coordinates are identical. So if you follow the same idea, I think right off the bat, before we even calculate the slope, we know that the equation of the line has to be y is equal to 4. So the equation of the line is y is equal to 4. It has to be. The y coordinate is the same in both ordered pairs, so it has to be. Now, if this is true and we have a horizontal line, then what that means is our slope should be 0. And we're going to prove that. So m is equal to y2 minus y1, 4 minus 4, over -3 minus 1. Let's check it out. This leaves us with 0 over -4. And when we do the math, we find that the slope is 0. That makes total sense to me. Anytime we have a horizontal line, our slope is going to be 0, right? So there's no rise or run, there's no rise or fall, but there is a run. Now, if this is tripping you up because the negative's in the denominator, don't let it trip you up. We could rewrite this as -0 over 4, but this has no meaning other than 0. So technically that is the same as 0 over 4. So 0 rise or fall, but a run of 4 units. So if you were to graph both of these points on the same coordinate system, you will see you have to move 4 units in order to get to the next point. Okay, beautiful. Let's go ahead and turn the page. For this next section, we have an opportunity to practice using point slope form to then derive slope intercept form. So again, if you're ever given a point and a slope, you're able to use point slope, just plug it right in. If you're ever given two ordered pairs or 2 points and you don't have a slope, what that indicates is the need to find the slope first using the slope formula and then plug it into point slope. So once we actually have point slope form, we can go further with the math to derive our slope intercept form. It's a nice flow through the problem that will never really need to change at all. So if you have 2 points, find the slope, point slope, slope intercept. It'll always work that way. Let's take a look. Write the equation of the line in point slope form and slope intercept form. So we're looking for 2 of them with the given conditions. So for part A, we're given 2 ordered pairs, a -2, 2, -1, 7. What this tells us is we need to find the slope first. So step number 1, slope. So we've got m equals y2 minus y1. So that's going to be 7 minus 2 all over x2 minus x1, -1 minus -2. Let's go ahead and do that math. So we have m is equal to 7 minus 2, which is 5, -1 plus 2, we're going to go ahead and make that correction, -1 plus 2, which is 1. So technically, we could just say that our slope is 5. There's our first piece. Now that I have slope, I can plug in a point and this slope into point slope form. So let's write out step 2, point slope form. I'm going to use my first ordered pair, my x1, y1, and my m in this form. Recall that we will only replace the y1, the m, and the x1 with our given pieces of information. So my point slope form becomes y minus y1, which is 2, is equal to m is 5. We've calculated that, so we need to plug that in, times x minus, now I want you to notice it's going to be x minus a -2. We're not going to write x minus a -2. We're going to clean those signs up. So instead of -2, it's simply going to be +2. And that is your point slope form. Point slope form has to have parentheses and your signs need to be cleaned up. No double signs, okay? We need to clean that up. So here we have point slope form, we're done. For step number 3, we need to find slope intercept form. Now, to make that happen, all we have to do is rewrite our point slope form. Y minus 2 is equal to 5 times x plus 2. And now we have to move forward mathematically. So if I were to ask you what first step you would take, your gut instinct will be, well, let's distribute to drop parentheses. We always want to distribute to drop parentheses. So that leaves us with y minus 2 is equal to 5x plus 10. Now, slope intercept form is y equals mx plus b, meaning that y must be by itself. So to make that happen, we're going to go ahead and add 2, bring it over to its like term, and that will leave us with y is equal to 5x plus 12. And that is slope intercept form. Just by looking at this equation, we know that our slope is 5, but we also know that our y-intercept is 0, 12, right? Your y-intercept is your b term, and it's always going to be an ordered pair. When you think about where a y-intercept is located, that's going to be on the y-axis. The only way there can be a point on the y-axis is if our x-coordinate is 0. Similarly, let's extend this a little bit. If I asked you to find the x-intercept for this particular equation, You want to think about, well, if this line crossed the x-axis, that must mean that the y-coordinate would have to be 0. So something like 2, 0, that's an x-intercept. Or negative 7, 0, that's an x-intercept. So we'd have to force y to be 0 in order to calculate that x-coordinate. We will see that later in these notes, but it's not a bad idea to calculate it up front so we can get used to doing that. It's a nice refresher. Let's take a look. So if I wanted to find the x-intercept, I can't write today, we're going to make y 0. So let's go ahead and plug in 0 here. So we have 0 is equal to 5x plus 12, which, by the way, we could have plugged in a 0 here. It doesn't matter. We'll end up with the exact same thing. So I'm going to go ahead and subtract 12 because my goal is to isolate my variable, right? That's always the goal. We want to solve for the variable. So I just found that my x-intercept, as crazy as this might seem, is the ordered pair negative 12 fifths, comma 0. If you plugged in negative 12 fifths into your calculator, you get negative 2.4. So this line will go through the ordered pair negative 2.4, comma 0. You can even go ahead and use Desmos or any kind of online graphing calculator to have a visual. I think the visuals are super helpful. So definitely plug that in. Okay, let's keep going. B. Notice here we're actually given the intercepts, but they're still ordered pairs. So the idea of needing to find the slope, that doesn't go away. Needing point slope, that doesn't go away. Using that to calculate slope intercept, that we can play a little bit. We could play around with that a little bit, and I'll show you. So step number 1, we still need a slope. So we have m equals, we've got y2 minus y1, so we have 5 minus 0 over x2 minus x1, or 0 minus negative 1/2. Let's do the math. This gives me 5 over positive 1/2, and 5 divided by 1/2 is simply 10. So I just found the slope. If that's weird to you, remember fractions when you divide, you keep, switch, flip. So this would become 5 times 2 over 1, and that's going to give you 10. Next, we need point slope form. So again, no big deal. And by the way, you can use either ordered pair. You could use your first ordered pair or your second ordered pair in your point slope form. All that happens is that instead of y minus y1, it would be y minus y2 is equal to m times x minus x2. Notice I have to be consistent. So that's completely up to you. And for the sake of just being different and having fun with this, I'm actually going to use the second ordered pair as my x1, y1, okay? So we have y minus my y coordinate, which is 5, is equal to m, which is 10, times x minus my x1, my x1 coordinate here, which is 0. There's my point slope. No big deal. If I wanted to use the first ordered pair, that's totally fine. So I'm going to write or, and that would be y minus 0 is equal to m, which is 10, times x minus a negative 1/2. So that's going to be plus 1/2. So either of these equations will be totally fine for point slope. Now, I mentioned a second ago that for the slope intercept form, we actually have our information here. So I technically don't need to solve either of these equations to isolate y. I can just simply write my slope intercept form. And I'm going to do that because I want you to notice that you have the freedom to do so. Slope intercept form is y equals mx plus b. Well, we know the m. It's 10. So 10x plus, and we know b. B is the y-intercept. It's right here. It was 5. And that is your answer. Now, if you don't believe me, take either of these equations, distribute to draw parentheses, isolate y, and you'll get the exact same equation. Cool. Go ahead and turn the page. For part C, I'm going to let you try this out. You're already given the slope. So you want to start with point slope and then move into slope intercept. The only difference here is it gets a little bit uncomfortable because we have fractions, but you know how to deal with fractions. You know how to add or subtract them, LCD. You know how to multiply, just go left to right, you're right, multiply the numerators, multiply the denominators, and if you have to divide, you keep switch flip. So I'm not going to show you that over the video, but it will be in the notes. Take a look later to see the uploaded scanned notes and see if you got the exact same answer that I did. Okay, very cool. Let's move into the next section on graphing using slope-intercept form. This strategy of graphing using slope-intercept form tends to be the favorite technique. And the reason for that is slope-intercept form is nice. We have two pieces of information. We know our slope, so I'm going to go ahead and circle that here. I'm going to rewrite it. Our slope is 3/7 in this case. And we also know our y-intercept. Remember that your y-intercept should always be written as an ordered pair because that's a point on the grid. So that's going to be 0, -2. Now, our slope is positive, so that means we're going to rise before we run. In order to actually graph this, even though we have function notation, it behaves the exact same way. We are going to start by plotting our y-intercept, right? Because that's the only point that we have. And then we apply the slope. That slope is a rate of change. It's movement, okay? So we're going to start at 0, -2. Here it is on our y-axis. And then we're going to rise 3 and run 7. So 1, 2, 3. And then we're going to run 7. 1, 2, 3, 4, 5, 6, 7. Now that I have my 2 points, I can go ahead and take a straight edge. I'll just use my sticky notes. We take a straight edge and we connect those dots with a line. Draw arrows on either end, and that's it. We are literally done. So yes, we had function notation, f of x is equal to 3/7 x minus 2. That still means the same as y equals, okay? F of x is another representation for y, okay? Beautiful. Let's go ahead and turn the page. Notice here with part B, we are actually given standard form. We're not given slope-intercept form, which is totally fine. So what we're going to do is we're going to start by isolating y. So we're going to subtract our 2x. That leaves us with 4y is equal to, now remember, we want mx plus b. So we want our -2x term to be written first. Also, that's descending order, excuse me. I need to get rid of that positive. 1 second. Here we have 4y is equal to -2x minus 16. I'm almost set. I need to get y alone. So that means we need to divide each term by the same value, which is a coefficient of our y. So divide by 4, that leaves us with y is equal to, always reduce, always simplify, -1/2 x. There's our slope, -1/2. And then -16 divided by 4 is -4. So let's go ahead and write this out. Our slope is -1/2. And our y-intercept is the ordered pair 0, -4. Now, because it's -1/2, this implies we fall 1 unit and we run 2. So let's go ahead and graph this. Start with the point 0, -4. So we'll carefully 1, 2, 3, 4. Here we go. And then we're going to fall 1 unit and run 2. Notice I'm not running backwards. I never run backwards. Fall 1, run 2. I'm doing it again. How about one more time? I found several points so that way it's very easy to ensure that this line is perfectly straight. So we're going to line that up, connect, draw some arrows, and voila, we are done. Cool. Nice recap on graphing using slope-intercept form. Now we're going to graph vertical and horizontal lines, or by finding those intercepts. So we already described earlier that we know the equation of every vertical line is x equals a number. The equation for every horizontal line is going to be y equals a number. And then if we want to find the x-intercept or the y-intercept, we have to plug in zeros. So the x-intercept means y is 0. The y-intercept means the x is 0. Let's take a look. Let's start with 3x minus 9 is equal to -6. So we're going to graph and we're going to state the intercepts. So there's only one variable. which means I know that I am going to be graphing a vertical line. 3x is equal to 3, divide, and we find that x is 1. So we're going to start by plotting where x is 1, which is here. That's the ordered pair 1, 0. Now, because x is 1, that means I need to plot any other point so long as x is 1. And I'll plot a couple just to drive this idea home. In each of these ordered pairs, x is 1. It doesn't matter what y is. So we're going to plot the point 1, 1, and then 1, 5, 2, or 2, wow. 1, 2, 3, 4, 5. I can count. I totally can. I know it. So we have our 3 ordered pairs here. Let's go ahead and connect with a straight line. Draw arrows on either end, and that is our line. So we have a vertical line, x is equal to 1. We plotted the points. Now the intercepts. 1, 0, this represents the x-intercept. Notice that it runs parallel to the y-axis, which means it's never going to cross the y-axis. So we can say no y-intercept. And that's it. So we have our 2 intercepts, and we've graphed the line. Go ahead and turn the page. Let's try it again. This is a great place to pause the video, try these on your own, and then come back and check. Let's take a look. Here we're going to solve for y this time. There's no x variable, so this is telling me that when I go ahead and do this, I'm going to have a horizontal line. So we show that y is equal to -2. So we're going to start off by graphing that point where y is -2 on the y-axis. So we're going to go down 2 units, and here we are. That is the ordered pair 0, -2. So this represents our y-intercept. There's our first one. Now, it does not matter what value our x-coordinate takes, so long as our y-coordinates remain -2. That's the beauty of this. So I always like doubling. So if I have -2, I'll go -2, -2, because why not? It makes life really easy. And then I'll just pick any other value. How about 1, -2? So we have -2, -2, which is right here. And then 1, -2, which is right here. Let's go ahead and connect with a straight edge. And I'm going to make this as straight as I possibly can. There it is. Draw arrows at either end, and there's our graph. Notice this line runs parallel to the x-axis, which means it's never going to cross the x-axis. So in terms of the x-intercept, there is none. So no x-intercept. Perfect. For part C, if you've already started this or if you've already completed this, you'll know you have both an x and a y-intercept. Both variables are here, so we will be crossing both axes. So let's take a look. Let's put this in. Okay, so there's a couple things we could do. The first thing is we could put this in slope-intercept form and then graph. Or the whole point is to find the intercepts. So why not find the intercepts and then connect them with a line? And then there's our graph. So we do all of them at the same time without having to take these extra steps. So that's the approach I'm actually going to take. Let's find the intercepts and then we'll graph the line. Okay, in order to find the x-intercept, we need y to be 0. So I'm going to take this equation as is. I don't need to manipulate standard form. That's never been a thing. All we have to do is substitute 0 in for y and then solve. 2 times 0, that goes away, right? Because 0 plus -5x is just a -5x. So now I can solve for x by dividing by -5. That tells me that my x-intercept is the ordered pair 2, 0. Cool, that's pretty sweet. So I can actually graph that 2, 0. Notice that's right here. It's on the x-axis, so everything's perfect. Next, let's find the y-intercept, and we do that by forcing x to be 0. So we have -5 times 0 plus 2y is equal to -10. Notice this first term goes away, so 0 plus 2y is simply 2y. 2y is equal to -10. Let's solve. Divide by 2 we get that y is equal to -5, which means my y-intercept is 0, -5. Let's go ahead and graph that. 1, 2, 3, 4, 5. And now let's connect with a straight edge. So instead of going through the process of isolating y, finding the slope, finding the y-intercept, and then calculating the x-intercept, we went ahead and just found those intercepts here. Now, the cool thing about this visual is I can actually just count to find the slope. If the question was, hey, what's the slope? We could say that to get from one point to the next, notice we're rising. The slope is rising. We're going uphill. We always read a graph from left to right. So reading from left to right, you hit the line and you're going uphill. So that means we have to rise 1, 2, 3, 4, 5 units and then run 1, 2. So we had to rise 5 and run 2. If you went ahead and wrote this in slope-intercept form, you would see that your slope is 5 halves. Very nice. Go ahead and turn the page. Next, we have parallel and perpendicular lines. Parallel lines literally run parallel, which means they'll never intersect. And the only way something like that could happen is if the slopes are identical. That's really, really important to know. So if this slope was, I don't know, -1/2, then the slope of this line has to be -1/2 in order for them to be parallel. Now, two lines are perpendicular if they cross at exactly a 90-degree angle. Now, you're not going to take out a protractor to measure, hey, is that 90 degrees? Instead, what you're going to do is you're going to see if the slopes are opposite reciprocals. So you have to have both of these pieces in order for those lines to be perpendicular. So for instance, let's say that the slope of this first line was a -1/3, and I'll even write it down. This is just an example. It might not be -1/3, but I'm just taking a guess. So if you had to fall 1 and then run 3 to get from one point to the next, then this line that is perpendicular would have a slope that's positive, right? Because this one's negative, so this one should be positive. It has a slope that's positive, and instead we're going to rise 3 and run 1. So notice that they are opposite signs, positive, negative, reciprocals, 3/1, 1/3. They have to have this in order to be perpendicular. So with that information, let's take a look at problem number 5. We want to write the equation of the line, again, in point slope and slope-intercept form with the following conditions. We would like to find the line that is parallel to this equation, but it's got to go through the point 1, 1. So because we're given the information that the line is parallel, all this means is that it must have the same slope. That's what it means. That's literally it. That's all you're going to take. So if I'm looking at this line, y is equal to -2/3 x plus 4, I'm going to say, well, I know what the slope is because it's the same slope. So both lines have the same slope of -2/3. However, my new line, the one that I'm writing the equation for, has to go through the point 1, 1. So I'm going to start with point slope form. You know we have to, considering, A, it's asking us to find that, but also we're given a slope and we're given a point. So it only makes sense to use point slope form. So let's plug this in. We have y minus y1 is equal to m, which is -2/3, times x minus x1. Cool, that's it. That's point slope form. We're done. Now we're going to rewrite this so that we can find slope-intercept form. Right here. So we have y minus 1 is equal to -2/3 times x minus 1. We know we must distribute to drop. Y minus 1 is equal to -2/3 x. A -2/3 times a -1 is a positive 2/3. Now we're going to add 1 to both sides. That leaves us with y is equal to -2/3 x, and then plus, now you have 2/3 plus 1. Remember, this is a whole number, right? And it's just a 1, but we have to have the same denominator. So wouldn't it make sense that we can replace a 1 with a 3/3? because then they have the same denominator. So if this is a 3 over 3, then 2/3 plus 3/3 is 5/3. Verify that on your own. You know how to add fractions. Do a little bit of side work. Prove that 2/3 plus 1 is in fact 5/3. And that is your final answer. Go ahead and turn the page. Our very last problem of this section is to apply the same concept, except this time our line is perpendicular. This is another great opportunity for you to try this out. You know what it looks like for two lines to be perpendicular. You know what their slopes look like. Try to take that information, use the appropriate slope and the ordered pair you're given, and then see if you can find the point slope and the slope intercept form. So I will start you in the right direction, and then I'll let you finish it, and you can take a look at my scanned notes and see if you got the correct answer. Okay, so I'm going to start this for you, but then I will stop the video because you can do this. All right, let's take a look. We know that our equation is y is equal to negative 5x minus 11, but we want our line to be perpendicular to that. So that means the slope must be opposite or opposite sign, and it must be the reciprocal. So if my slope originally was a negative 5, that means my new slope is a positive 1 over 5. So use this information and your ordered pair, negative 4, 5, to find the equation in point slope form and slope intercept form, and then try your hand at the problems in our practice block under lines. You could do this, and good luck. I'll see you in class. Bye.